Hello everyone. In this session we have to discuss about the open shortest path first packets. So the OSPF protocol, generally it uses the 5 different type of packets. So the first one is hello, second one is data description, third one is link state request, link state update and link state acknowledgement. So you can see the link state update, it uses the different type of link, that is the router link, network link, summary link to the network, again summary link to the ASI, boundary router and external link. So generally the OSPF uses this 5 different type of packets. So first of all we have to see the first type of packet. What is the functionality of first type of packet? That is the hello. So hello packet, it is generally establish and maintain the adjacency information with the neighbors. Type 2 type of packet, that is the database description packet, DBD. It describes the content of link state database on the OSPF router. Type 3, that is link state request, LSR, request the specific pieces of link state database. Type 4, OSPF packet type, that is the link state update. So this packet transport the link state advertisement to the neighbor router. And the type 5 of type of packet, that is the link state acknowledgement. So this type of packet acknowledge the receipt of the neighbor's LSA. Okay, so this 5 types of packet which is used under the OSPF protocol, and it having the different functionality. As we have seen from this, the hello packet, it is establishes and maintain the adjacency information. DBD packet, it describe the content of link state database. Link state request packet, it requests the specific pieces of link state databases. Type 4, that is the link state update packet, it transports the link state advertisement to the neighbor router. And the link state acknowledgement packet, it acknowledges the receipt of the neighbor LSC. So this is different type of packet which is used under the OSPF protocol. So now we have to see which is the common header which is used between all these packets. So all the packets from type 1 to type 5, they having the common headers. So in this common header you can see this is the common header format of this OSPF. So in this you can see the version, it is of 8-bit. The type, so version, it specify the version of the packet. Type, it having also, it is of 8-bit. It represent or it specify the type. The third one part, so it is the message length, it specify the length of the message. In this common header, again we are specifying the source router IP address. So this source router IP address, it specifies the IP address of the source router. Again, in this common header, you can see the checksum authentication. So checksum, it is of 16-bit, authentication type, it is of 16-bit, and authentication, it is of 64-bit. Okay, so this is the common header which is used for all the types of packet. Okay, so I'm just saying that the type, so in this, the type, it represent or it is 8-bit field which define the type of packet. The message length, it is of 16-bit field, it defines the length of total length including the header. Source router IP address, it is of 32-bit and it defines the IP address of the router that sends the packet. Area identification, here we are specifying the area identification. So the area identification, it is of 32-bit field. Again in this common header we are using the checksum. So this checksum, it is used for generally the for the error detection on the entire packet, excluding the authentication type and authentication data field. Next one, in the common header of OSPF packet, you can see the authentication type. So this authentication type, it is of 16-bit, and this authentication type defines the authentication protocol which is used in this two area. So it having the two type, we are specifying the authentication type value as 0 means none, and the authentication type value 1 means password. And the last one block in this, in the common header of the authentication, sorry, in the common header is the authentication. So authentication, it is of 64-bit. Okay, so this is the common header that we are used for all the type of packet under the OSPF protocol, and it having the 5 packets. Okay, so first of all we have to see the first one, that is the link state update packet. So link state ls type means link state type packet. It indicates the type of link, and it describes the various link types. So the first one, if we are using the value 1, so it specify the router LSA means link to a router. If we are using the value as a 2, so it specifies the link to a network. If we are using the value 3, so it specifies the summary LSA means IP networks. So when area are used, summary information generated about the network. If we are using the value 4, so it represent the summary LSA, that is ASBR. So ASBR, it is being used when the particular area it is being used, and the summary information about the link to an autonomous system boundary router means AS boundary router. So we can say that the summary LSA, it is used when the particular area it is being used, and summary information about the link to an AS boundary router. And 5, this value represent the AS external LSA. So it represent an external link outside the autonomous system. So we are using the different links type, that is the router LSA, network LSA, summary LSA, IP network, summary LSA, ASBR, and AS external LSA under the link state update packet. So you can see in this link state update packet, it is a heart of the OSPF operation. It is used by the router to advertise the state of its link. It having, or it uses the common header which we have discussed earlier. In this, with the common header, it having the number of link state advertisement, it having the link state advertisement, and under the link state advertisement we have already discussed the 5 different types. Okay, so in this each packet it contains the several different LSA, and all having the same general header, that is this one header. In this we are using the link state age, or we can use this packet format with the common header in the link state update as a link state update packet. So this is all about the link state update packet and how we can use the different link type under the link state update packet. And we have already discussed the OSPF packet common header, which is used for all the 5 types of packet. So thank you for watching.